Hi, my name is Jessica with Greenleaf Consulting, and today we're going to be doing a demo about Databricks Materialized views and the different ways that they can be refreshed, either an incremental refresh or a full refresh. Now, this is a feature that can come into play a lot if you have some sort of an architecture where where you find yourself loading data into, say, a gold layer or a presentation layer. The data could either be aggregated or it could just be, it could be transactional, but you're adding some calculations to it. It could be whatever the destination table might be. And I know that a lot of times in the past, the architecture that, and I've been guilty of it, I know we all have, is when you want to quickly create something in the presentation layer, you create a query, you load the table, and then, oh, it turns out you have to schedule it. So instead of setting up any kind of incremental load, the quickest thing to do is just have the table dropped and recreated every day. And that works fine. And then all of a sudden, eventually you have 10 million, 20 million rows, and you're dropping and recreating that table on a daily basis, which is obviously not best practice and not good for our costs. So this materialized view incremental versus full refresh ability is something that can help us deal with that problem. What you're going to see here is first I've already created, I have my demo _MV materialized view catalog created, and I've created a destination warehouse schema and a source OLTP schema that has a raw data volume created in it because we're going to move some files in there to use as our source. So if we go back here, okay, the first things that we're going to do is we're going to do our housekeeping here. We're just going to set the catalog and schema that we're going to use. Those are already created. We're going to drop the objects that will be created through this demo. And if I had files in that raw folder, this dbutils.fs.rm, and then the volume path, this would delete those files. And then what we're going to do is we're going to get data from the Databricks data sets themselves, and you'll find on the Databricks websites and in their documentation that they'll have a few different data sets that that they'll point to in their documentation. But what I found is that they also have quite a few data sets that are readily available, I guess, already within the file store for Databricks itself. And so by just doing display dbutils.fs.ls and this right here, / Databricks datasets / we can see that Databricks already has a bunch of these different folders with all kinds of different data sets in here. And I have to assume that this taking data from here, you're probably saving a few pennies on because you're not doing any kind of ingress of the data, but don't take my word for that. I assume that that's how it works. Regardless, it's an easy place for you to get data from. There's different kinds of data. There's some that's JSON, there's some that's CSV, there's transactional, there's streaming data. So anyway, that's just a quick place that you can look to get data, and that's what we're going to be using today. So right here, I have, I'm looking at the NYC taxi data sets here. These files are all zipped, but Spark lets us read those without having to actually unzip them. So what I did here, in this case, we're just going to take 3 of these files. We're not going to deal with any more than that. And I just set up a quick, a quick script here. I listed out the files that I want. I'm just going to loop through that array, and I'm just going to copy those into the volume that, like I said, I had already created, that source OLTP raw data volume. And so let's do that. And there you go. See, it's just going to copy those 3 files. And just to show that we can read from them without doing an unzip, we can just do read files and then volumes, demo, and v, source OLTP, raw data, file name, you can see it's .gz. And if we just do a select count, we'll be able to read from that. So that'll come back in a second. So what we're going to do now is from those, and we're going to start with just one file. From that data, we're going to, each file I think has around 7 million records in it. What we're going to do is we are going to create a table in the source OLTP schema that's just called taxi trips. And what we're going to do is we're going to, there's a vendor ID, we're going to use that as our partition key. There we go. So see, about 7 million records in the first file for October of, what is this, 2019. But so what we're going to do is we're just going to take all the columns out of that file, that data set, but we're going to add a unique GUID to it. And that's just so that later on we're going to be able to update one row at a time because there is not an identity column built in. There's other ways you can set up an identity column for Databricks. You can, there is actually an identity, there's an identity column type that you can create on DDL when you create a table, similar to how you would in SQL Server, but that's a different demo. This is good enough for now. So let me run this. And I'm going to pause the recording and jump around. I'm going to do that a little bit, a few times throughout this when things take a little bit longer. So, okay, so that took about 45 seconds to create that, that taxi trips table. And if we don't need to do a count, we know how many records there should be in there, but let's take a quick look at the data that's in there. Okay, so as I said, we added this trip ID column. The vendor ID is null for, I think it was a few tens of thousands of records, but the vast majority of them do have vendor IDs, and I just chose that as the partition. So we have a pickup date time, drop-off time, distance. We have IDs that relate to, I don't have the lookup table for this, but I guess relate to pickup location and drop-off locations. And then we have a number of measure fields here. We have the fare amount, extra dollars, MTA tax, tip amount. I don't know why these are 0. Tolls and some other surcharges, and then a total amount. And so what we're going to do is we're going to just create a dummy calculation, or just a calculation that changes some of these measures to use in our materialized view. And that'll be our, that's our simplified business logic that we're going to be using. So what we're going to do is in Databricks, like we said, materialized view is a read-only object, and it's defined with a query behind it. Unlike a quote-unquote regular view, the data is actually materialized. So that means it's actually stored in, it's actually stored on disk as an object. One thing to be aware of with the materialized views, though, and this caught me when I was first trying to put this demo together, is that the materialized views, and we can see I have a create script for it right here. So we just do create or refresh materialized views, put it in the destination warehouse schema, and we're going to call the new materialized view new pricing analysis MV. And so we're selecting all the columns. And then, like I said, we're just doing a simple calculation. We're going to increase the fare amount by 20%. Let's pretend that's some kind of an analysis. And so we do that for proposed fare amount. And then we do the same. We add all of the other columns together and add in the proposed fare amount for a new proposed total amount. So if we were to do this and go ahead and create this, or try to create this table, what we would need to be aware of, or this materialized view rather, is that you have to set something up in order for the data to actually be refreshed. Depending on the documentation that you read, it was, at least to me, it was a little bit confusing at first. I think that at first I had assumed that the materialized view would itself either, maybe some kind of like a lazy read each time you run it. It's going to rebuild it would rebuild the materialized data underneath, or at the very least, it was on some sort of a set schedule, or it had some kind of a feature where it checked the underlying tables. Anyway, none of that is true without any intervention on your part. So if you just create the materialized view and do nothing else, it will never be updated. What you need to do is there's a few options that we'll take a look at one in a second, is when you create the materialized view, you actually will, it actually will also create a pipeline that is effectively, or not effectively, it is what is run behind the scenes. And so let me see. Oh, so no, I deleted it before, so it's not there, but we'll get back to, we'll show that in a second. And so you either have to schedule that pipeline that will be created, or there's also a trigger on update clause that you can add to the materialized view. For this case, we're not going to use that. And then, of course, the last option would be that you manually would you can manually refresh or just recreate the materialized view, and that would cause it to try to do either a full refresh or an incremental refresh, which we will talk about in a minute. But first, if we go ahead and we try to create this materialized view right now, you'll notice that I'm just running on regular serverless here. It's going to fail, and it's going to fail because the materialized view operations create or refresh is not allowed, cannot create blah 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 from general compute. Please use DB SQL serverless recommended or pro warehouse. So what that's saying is that you can't use the standard serverless option that you can use when most of the stuff that you're running for Databricks. So what you need to do is you actually need to use one of the SQL warehouse options that they have. The serverless starter warehouse is the one that's I think is set up whenever you create your account. And just something to keep in mind, I think when I first opened my account with Databricks, the default that this was set to, I forget if it was medium or if it was small. Either way, I changed it to 2 extra small, which is the smallest size you can get, and I set the timeout to whatever the lowest is, just because right now this is my personal account. I don't want to run up a bill, so you will need to do that going forward. Then, of course, it does warn you when you switch to SQL that you're not going to be able to run anything in Python without switching back to the general compute serverless. So we will switch to that. I will run this here. Again, this is just going to be creating another calculation at the transactional level from our taxi trips table. I will run this and pause the recording until it completes. Okay, now that that's run and that's complete, that took about 45 seconds. It tells us the operation was successful. Now, like I said, what that actually does is that creates behind the scenes up there, just popped up. If we go to the Jobs and Pipelines tab, we can see that it actually creates this pipeline, this pipeline that is used to load that materialized view or to refresh it. It marks it as a materialized view pipeline, just kind of gives it this generic name, and it has one recent run because that's when it just ran itself. We have the option to start it, but any other edits, it tells us that we need to do via the create or replace SQL statements. So we can't just change the pipeline here. We can only do that via the SQL statements. Now we could go ahead and we could schedule this within a job if we wanted to let's say run it every day. That's probably what you would end up doing in the scenario that we talked about, where you're loading something into a presentation layer with calculations or aggregations. But for now, we're just going to leave that as is, and we're going to just do it manually. And so before we really get into doing any of these other data updates to see how the incremental and versus the full refresh works, there's one other interesting thing that I wanted to bring up here, and that is that, so we're going to be talking about underneath the hood, and this would be a whole other demo that maybe I'll do a part 2 on at some point. We're going to touch on this a little bit later on, but this would be much longer if I went too deep into this, because I went down the rabbit hole trying to figure it out before this. Is that there is a cost optimizer in Databricks that when when you run the refresh for the materialized view, while you can explicitly tell it to do a full refresh, the default is that it uses its own cost optimizer to try to decide whether or not it can do an incremental update, or whether or not it can do or it's more cost effective to do a full refresh. And what I learned with some of my reading is that it tries to, or it heavily weights by default, the cost optimizer heavily weights the incremental version of the incremental load. And the little bit that I read about that was that it does that because even if the cost that it decides, even if it decides that the incremental load will have a higher, like on paper cost, it kind of makes the assumption that it's better to just update the data in the materialized view rather than recreating the table because of any potential downstream effects that might have. So that was what I read. I didn't dive too much into how that cost optimizer works. But to that point, there are some, depending on what we do with our materialized view, there are some things that simply cannot be done or cannot be done as incremental refreshes. And so what we will see now is that this guy right here, there is a command that you can run that is explain create materialized view, and you just have to give it any name. This does not actually create the materialized view. It is explaining the creation of it. So this is what we wanted to use, the transaction level materialized view. And what we're going to see with this, oh, is it going to make me switch back to... Okay, that is the problem with setting the timeout of the SQL warehouse to be its lowest amount, is that it times out when you don't mean for it to. So what I did was I ran this after I spun that back up. I ran this explain command, and what it shows us is it actually gives us some detailed information about this specific query that we're trying to use in a materialized view. And so what it's actually saying here is that it says detailed incrementalization information, row tracking not enabled. Oops, actually, I thought there was another line here. There it is. It says incremental update eligibility. The materialized view cannot be incrementally refreshed. See detailed information. The detailed information talks about row tracking on this taxi trips table. So what this is saying is that because of the type of query that this is, in this case, because it is not aggregated, it is just a one-for-one reading and calculation from this taxi trips table, is that unless we enable this other feature, which is row tracking, on the taxi trips table, we will never see the benefits of an incremental refresh. It will only do a full refresh each time. Now, counter to that, if we, and this, we'll just use this as an example, if we do the same explain create materialized view, and it's an aggregated data set. So here we're grouping on vendor ID and the pickup date and pickup location, and just doing a sum of one of the charges, we'll see the incremental update eligibility is that the materialized view can be incrementally refreshed, no issues detected. And the bit of reading that I did about that is that it is because originally you think row tracking, well, excuse me, you think, okay, well, I have the delta log, so isn't that in and of itself row tracking? As I read things, of course, yes, it is row tracking, because with Delta Lake, Delta tables, you can do a point in time restore. But I think that enabling the row tracking must I guess it gives the cost optimizer, it gives Databricks a better or easier view to actually find the specific changes. Whereas with if you're doing something that involves an aggregate, and you do not have to have the row tracking turned on in the base table, because at that point, I think because it knows that it's doing a group by, it can use what's, I'm going to say, quote unquote, built into the Delta log table to be able to prune out some of the files and be able to get a benefit from doing an incremental refresh by just using that metadata that it already has. Another thing to just be aware of, and this is the other reason that you can run this explain, create, materialize view, is that there are some functions, some features that might not be compatible or are not compatible with an incremental refresh. So you can look up that on the documentation, or just always make sure to check your own whatever query it is that you plan to do. Obviously, we're doing very simple queries here. So with that said, what we're going to do is we are going to set the we're going to set this property to enable row tracking on our source table here. And let me just, since I did that, let me just recreate this real fast. Just, I'm not sure whether or not it's different, but since I just set that property, so we reran this materialized view, and in this case, let's see here. So let's take a quick look at, if we click on the C performance here, if we go ahead and we look at, if we click on this to get some detailed information about it, we can see that since this is the first time that this has been rerun, we can look at some of the stats here, and we can see that it read what we would expect. It's read 7.2 million rows. I'm actually not sure why that's slightly different, but the bytes written and the bytes read. This is going to be something that we're going to look at going forward, because with in theory, with incremental updates and stuff, we should see much smaller reads and writes of both rows and bytes when we get the benefits of the incremental refresh for the materialized view. Whereas if we were to just do a if we were to just create a regular table based on this exact same query, just load it into the table, then we can check what the stats are on that. And let me run this. Okay, we've loaded our physical table, or the materialized view is physical too, so strike that. We've loaded our regular table, we'll call it, and we just called it new pricing analysis table. And again, if we take a look here and we go and take a quick look at the performance here, we're going to see that again, we have rows read and rows written, and the bytes read and bytes written. So we have to remember that if we were to do a drop and recreate for this, let's say we're doing that every day, this is going to be what we're going to see every time it reruns. So there's, it's always going to be doing whatever the file size is. It's going to be dropping, 180 megs. It's going to be writing 160 megs, whatever. But as we'll see going forward, with the materialized view, we will be able to see some benefits there. I also just want to make a quick call out that I'm not going to be paying attention or going into the actual wall clock time for any of these things, because as we know, especially since I have this set as a 2 extra small SQL serverless SQL database, I have no idea how that affects the timing of everything. We're strictly going to be looking at the reads and the writes for this demo.